Okay, let us solve a problem on symmetrical T-type attenuator design. So this is the problem question. What it is asking? It is asking us to design a T-type attenuator to give an attenuation of 60 decibels and characteristic resistance of 500 ohms. So we all know for designing an attenuator, we will be given with the attenuation value as well as characteristic resistance. So both are given here. No challenge, directly you can apply the formulas. But there is only one trick or one thing that you need to remember while applying formulas. These formulas, if you see R1 and R2, R1 is equal to 2R0 into n minus 1 by n plus 1, and R2 is equal to R0 into 2n by n square minus 1. These are valid, these two are valid for the T-type network. If you see here, for the T-type network, which is like this, where this resistor is R1 by 2 and this is also R1 by 2 and this is R2, fine, it is not a problem. So here, when this series arm resistances are R1 by 2, these formulas are applied. Of course, in case of T-attenuator, the shunt will be R2. There is no multiplier or division applied here. So only in case of series arm for T-attenuator, there will be either division. In some cases, we may not consider the division of 2. So if you see this formula is applied when the network is having R1 by 2. That is very important. Okay. Suppose, why I am saying this? Suppose in some textbooks you might be given with this kind of attenuator circuit where this is considered as R1 and this is also considered as R1 and this is R2. So this is also symmetrical attenuator, right? You might be seeing this kind of circuit in my notes. Okay, so this is also valid. For this kind of circuit, if you choose, the formula of R1 will be different. What will be formula of R1 for this kind of one? I will be writing here. So for that kind of circuit, R1 will be equal to R0 into n minus 1 by n plus 1. Okay, so this particular 2 will not be there. If you are considering, this 2 will not be there if you consider the circuit of just R1. So this is a very important point here. Without that, you might commit a mistake here. Okay, fine. Now, this textbook has considered R1 by 2, R1 by 2. So the formula is R1 is equal to 2 into R0 into n minus 1 by n plus 1. So if you see, for a given attenuation of 60 dB, it is capital N in dBs and R0 is in 500 ohms. And one more point here, this attenuation is given in dBs, but in this formula the N is not in dB. Okay, so we have to convert that N into nepers without dBs. So N in dBs is equal to 20 log 10 N, which is in nepers. So this N value you should be substituting in the formulas. Okay, this will be used in the formulas. Okay, these two are very important points while solving the problems of design of attenuators. So this is for a T-type of attenuator. Similarly, for a pi-type attenuator also there will be some difference. Like in place of R2, you might consider 2R2. Okay, so accordingly be careful and solve the problem. Okay, that's it. Thank you.